So loops in C# will look very, very similar, just about exact, to anybody who's familiar with C++ and Java, and only a little bit different for users of Python. So a while loop, pretty traditional. While condition, do something. As long as the condition is true, it'll repeat it. The for loop, you can create a variable inside the for statement, just like you can in Java, Python, and C++. For int x equals 0, x is less than, and then x plus plus, and how many times is that going to count? That's going to count 10, because it's going to count 0 to 9. If we change that, it'll count from 0 to 10, which is actually 11 pieces. If you change this, you can be changing the increment. X plus equals 10, that'll add 10 to it each time, right? X times equals 2, that'll multiply, double it each time. Although since we're starting at 0, it's always going to be 0. And we could do that, right? X starts off at 1, and we keep doubling it until we exceed, 1,000. Something like that. So your for statement can have more than one condition in here, if you want. You can have more than one initialization, and you can have more than one kind of update. If you want to You can put multiple tests in the condition area. You can do tasks other than incrementing at the end of the loop's execution. For example, if you want to call some method, you can do that. Perform multiple tasks at the end of the loop's execution by separating the actions with commas. Or you can leave parts of it blank. Right? If you don't want to initialize anything, just leave a semicolon there. X had better have been declared beforehand, or else that'll be a syntax error. If X is declared and initialized, we're good to go. That'll work. If we're going to update X inside the loop, we can leave that part off as long as we still have the semicolon. And if we're going to have a break statement in it, we can even do, while X, or if X is greater than whatever, then break. Something like that. Now, by the time you do that, right, by the time you initialize outside of it, you have your break inside and you have your update inside, you may as well not even be using a for loop. But you can. I can't argue why I would do that over just using a while loop. Absolutely cannot argue why I would do that. If I was going to do something like that, then I'd just make that a while true loop. To me, that looks like a while true loop. Does the same thing, though. So the do loop always enters the loop without testing, because it's a post-test loop. Do, print out X, and then X plus plus, while X is less than 10. So if we set X equal to 1, it's going to print 1, 2, 3, 4, 5, 6, 7, 8, 9. And it's going to stop at 9 because after X gets incremented and set to 10, this condition is no longer true. The condition happens after the body of the loop, so nothing prevents it from getting in here even if X was set to 1 million. Still come in here and it would print out 1 million. Then it would add 1 to it, and then it would no longer be true. Whereas if it was a while loop, whoopsie. If it started off with the condition while X is less than 10, but we initialized X to 1 million, it's not going to go into loop at all. So a do loop is represented like this with the loop body on top, and then the test goes like that. Python doesn't have a do loop. Java and C++ certainly do. Nested loops are when you have an inner and an outer loop. The inner loop has to complete completely before the outer loop can execute at least one time. It's like this. You have an outer loop and you have an inner loop. Did we do a nested loop like where we counted hours, minutes and hours, or where we printed out dollars and cents? Is that sounding familiar or not? Okay, yeah.
I think we did the triangle.
Yeah, we did.
Yeah, and we did a triangle. Okay, so we've done nested loops. The inner loop just has to execute completely, right? Like printing all the asterisks in a row before the outer loop will iterate once and go to the next line if you were printing out a rectangle or triangle or something. That's also how you print two-dimensional arrays or process two-dimensional arrays. Speaking of which, we're going to be talking about arrays just so that I can demonstrate a for each loop pretty soon. So to process data, sometimes you want to calculate a total with an accumulator. In that case, you have to assign an initial value to your total, to your accumulator. And then inside your loop, you add something to it. Like you ask the user for a value, you calculate a random value, get it from an array, something like that. And so all this is mentioning garbage is an unknown value. If you do this, int total, and you don't give it an initialization, it doesn't have a value. And so if you try to do math on it, it's going to fail. Or, if you try to add something to it, it's going to fail. So the C++ compiler shuts that down. It doesn't let that happen. It won't compile. Which is goodness, because C++ is happy to use garbage, uninitialized data, just fine. And then your program may work correctly, and then you take it to a different operating system, and it may not. So improving loop performance, make sure the loop avoids unnecessary operations. A loop should execute while x is less than the sum of two integers. You could do this while x is less than a plus b, but if you can calculate a plus b ahead of time, then it doesn't have to repeat every time. So in the code on the left, a plus b gets done 1,000 times, or whatever, along with the comparison. So that's 2,000 total statements that are executed inside the while. But here, if you calculate it just once, and then you do 1,000 comparisons, it only does 1,001 different statements. So this is considerably faster, ignoring the fact that the loop body also has to execute. So the arithmetic, the comparison to create this value, the assignment to create this value, happens only once, which is an improvement. So if you can avoid putting a function call or a calculation inside your while or your for, that is goodness. It'll speed it up a little bit. And C# is a fast enough language that performance, improvements actually matter, unlike Python. Using the prefix incrementer rather than postfix incrementing, believe it or not, ++x is slightly faster than x++. Employ loop fusion. Loop fusion is when you're doing two different things inside the same loop. Like say we really need to create an array so that we can demonstrate this stuff without having to ask for data each time. And then we're going to use a for each loop, but it'll illustrate the points. So I'm going to go ahead and make a new project, make a C# console application.
This is number.
I believe this is M. Let's take a look. Yeah. So loop fusion is just if you have two loops that are stepping through the same series. And you can combine them to be in a single loop. You may as well do so. For example, if you're going to write code that's going to add all the numbers between 1 and 10, and then multiply all the numbers between 1 and 10, calculate both the summation and the, oh God, I can't believe I just forgot the name of that, factorial, 1 times 2 times 3 times 4. You could do those in two separate loops, or you can do those at the same time. So let's calculate a sum. So we better create our sum variable, and let's calculate our product, or our factorial. But we better start it off at 1 because we're going to do 1 times 2 times 3 times 4 times 5. And then constant max equals 100. We're going to add up 100 numbers. That's going to get awfully large. I'm not sure if factorial of 100 will crash or not. Guess we'll find out. Yeah, I'm sure it is. I'm just going to change that to 10. All right. And so now we're going to create a variable, a counter, for int I equals 1, I is less than or equal to max I plus plus, all separated by semicolons. Now here's one thing we could do. I'm going to do a copy paste, but then I'm going to undo it. So you don't need to do it. Okay. So here's what it could look like. This is a perfectly valid solution for calculating both the summation and the factorial, which is all the numbers multiplied by each other. And I don't know why I have sum equals sum plus 1. That should be sum equals sum plus I. And this should be factorial equals factorial times I. And of course you could write this short, sum plus equals I. But anyways, why do 2 loops if we can just move this statement up and put it here, so that we only have 1 loop iterating and it's doing 2 things? Now why would you want to do that? Because you save 10 comparisons. Or if this loop's counting to 1,000,000, you save 1,000,000 comparisons. Right? Because if this is going to count to 1,000,000 and this is going to count to 1,000,000, that's 2,000,000 comparisons for it to work. Whereas if we just move this up in here, and that is our final answer, I'm not going to change that, then it's only going to do 1,000,000 comparisons plus the body of the loop. And so figuring out the performance of statements like this is actually something that you could study if you're going to take a 4-year programming degree somewhere. Calculate the amount of time, the amount of processor time, or the relative amount of time it would take to do this. And you would find that this is considerably more efficient. We have merged the 2 loops together. Merge loops together, if you can, to improve loop performance. And that's an example of merging 2 loops together. May as well add a comment saying what we're doing. Calculate the summation and factorial. Guess we could print them out. Why calculate them if we're not going to print them out? Textbook keeps showing just using write rather than console. Right? How do they do that? Do they have a using namespace in there? Now, I don't recall how the book's doing it so that they can just do write each time.
You have to use the word using for namespace?
Oh, that's right. That's C++. Put the word namespace in there.
So
Still not working.
Oh.
I don't know. Forget it. I'm not going to waste time trying to figure it out. I need to look at the code examples a little bit more clearly. So CW tab tab. Let's write out the sum. And then let's print out the factorial. Or is it just factorial? And I didn't put my console.read line at the bottom, so I will. CW tab tab. Hit enter to quit. Alright. Originally when I was thinking about setting it max equal to 100, I wonder what that would have equaled. Factorials increase so much more quickly than summation that, yeah, we've already maxed it out. It went past 2 billion really, really fast. So if we change that to a long, will it work? Nope. If we change it to a double, gonna work? Okay, that's a pretty large number, 9 followed by 157 zeros. So just by multiplying all the numbers from 1 to 100, you get a very large number. So that's one thing you can do to improve performance. Another is to make sure that you don't have any unnecessary calculations in here. I would not want to have a function call right there or some kind of calculation there unless I absolutely had to. Consider the order of evaluation for short circuit operators. I think we've talked about short circuiting before, so I'm not going to get into that again. And so if we want to check the time required to prove that plus plus x happens faster than x plus plus, we could enter this code. And it's actually worth doing because it's actually interesting. It shows some stuff we haven't done yet. We'd have to add, oh, there it is, using static system.console. That'll just let us use write. I went back here and did using static system.console. Why do I have the feeling it's not going to work? Forget. All right. Well, anyways, this uses something called the stopwatch to time how quickly it runs. It starts the stopwatch, it stops it, and then it creates a new stopwatch, starts it and stops it, and then it prints it out. That's kind of interesting. Let's see how many loops that wants us to do. How many zeros are there? 1, 2, 3, 4, 5, 6, 7, 8. That's 100 million times that they want this code to repeat. Let's see if we can get this going. So we're going to need system.diagnostics. So I'm going to come up here and add that. Using system.diagnostics, semicolon. Then I'm going to come down here. And const int.
That's past your.
I'm sorry, pardon me.
That's past your end program.
Oh, it is. Thank you. Save me some annoyance. This needs to be before the read line. Okay, so what are we going to do? We're going to test which is faster, prefix or postfix increment. That's what we're doing. So const int max underscore iter, just for, how about this max I? How about this max? Maxi. Equals, and we're going to do it to 100 million like they did. So it needs to have 10 zeros. 1, 2, 1, 2, 3, 4, 5, 6. That's 10. And we need to create our stopwatch, and then we're going to have our loop. Then we're going to stop our stopwatch. And we're going to create another stopwatch, have our loop, and then stop that one. So, oh, they called it loops. I can dig it. That's a good variable name. Constant loops equals 1, 2, 3, 4, 5, 6, 7, 8. All right, so stopwatch SW equals stopwatch.startNew. Stopwatch, all lowercase except for the S. SW1 equals new stopwatch dot, let me guess, parentheses dot start new. Yep. Nope. No parentheses. Maybe just get rid of that new. Stopwatch S1 equals stopwatch dot start new. Capital S, capital N. And then we just need a loop that does something, whatever it's supposed to do. They just have a simple loop that ends in a semicolon, which means it does nothing, which in my mind means that an optimizing compiler might want to take that out entirely, but apparently C# doesn't do that, which is goodness. So for parentheses int I equals 0, semicolon I less than capital L loops, semicolon I plus plus. And you could put curly braces like that, or you could do exactly what they did and just put a semicolon after it. Does the same thing. I'm going to leave the curly braces there. Now we're going to stop our stopwatch. So SW stop, or SW1 dot stop. SW1 dot capital S stop, parentheses in parentheses. Now do the same thing, just copy all that, but change all the S1s to S2s and change I to plus plus I rather than I plus plus. So we're going to make 3 changes. I'm just going to copy those 3 statements, paste them. Stopwatch SW2 equals stopwatch.startNew. And instead of doing I plus plus, we're going to make that plus plus I. And then we're going to do SW2.stop. And then we can convert those to milliseconds and see which took longer to run. We will find that the postfix I++ actually runs a little bit more slowly than the prefix. And it has something to do with how many times a memory location where I is stored is accessed. For some reason, doing it this way accesses that memory location a little more often than that one. Not sure why. Doing the same thing, adding one to it and storing back into it, but let's print it out. So what we need to use is s1.elapsed.total milliseconds and s2. Okay, so int m1 for milliseconds 1 equals s1 dot elapsed milliseconds, parentheses in parentheses. I seem to be getting an error there. I shouldn't have winged it. Okay, fine. Elapsed dot total milliseconds. Okay, so s1 dot elapsed with a capital E dot milliseconds. If I could type, that'd be dangerous. And let me guess, it was total milliseconds. Yep, all right. If I had any long-term memory. Total milliseconds. Please go away now, error. Oh, I'm gonna go fit.
It can't be a method, because that's the error wrong.
It's not a method? All right.
No, it's different from that.
What am I doing wrong? Am I just storing in the wrong data type and that's why it's complaining now? Cannot convert from int. Okay. So instead of int m1, make it a double m1. And then make copy and paste that and make it double m2 equals sw2. So double m2 equals s2 dot elapsed milliseconds. And then let's print them out. CW tab tab postfix plus plus ms equals end quote plus m1 in parentheses semicolon, and then just copy that and change it to prefix plus plus. Or how about I just make that I plus plus milliseconds equals, and then when I copy and paste that, I'll make it plus plus I. Then I'll pause it and make sure everybody's doing okay. Plus plus I milliseconds is equal to M2. All right. Wow, was not very long, was it? We saved a whole 2 milliseconds. I'm underwhelmed. Okay. If you ran longer, like you ran a billion, 1, 2, 3, 4, 5, 6, 7, 8, 9. See a slightly larger savings. Of course, it's going to take 10 times long. There we go, right? Ooh, a whole 6 milliseconds longer. All right, I'm really not impressed by the performance gain of using postfix versus prefix. How's it working for y'all? About the same?
The numbers I'm getting are completely different. That might be just because my computer runs faster?
Yeah, let me come look. When you do it to 10 million, how much does the postfix take?
0.004.
Okay, yeah, so your laptop isn't like way faster than mine, than this desktop computer is. So anyways, you could use this tactic to figure out which algorithm was faster if you needed to do some testing. You wanted to test some sort algorithms to see whether bubble sort was faster than a selection sort or something like that. Then you could use a stopwatch in order to do that. So using a loop is no different than using one in a console application. Event-driven programs sometimes require fewer coded loops because some events are determined by the user's action rather than by the program's coding. The user gets to pick when to quit, when to start. You can write an event-driven program so that the action continues as long as the user wishes, as long as they continue to make an appropriate selection. So how many greetings do you want? You type in something, you click the button, and then it goes and it prints all those. I'd be real interested in seeing the code for that. They're filling an output label, and they're adding a new line to their output label over and over and over to get additional lines to display. So chapter summary. Use a while loop to execute a body of statements continuously while some condition continues to be true. Use a for loop. It's the best loop in my opinion because you can specify the starting value for the loop control variable, the test condition, and the expression that alters it all in one line. But sometimes you need a do loop, although there's nothing you can do with a do loop that you can't do with a while true loop, that checks the bottom of the loop after one repetition has occurred, so it always performs the body at least one time. And you can nest any combination of loops to achieve what you want. So totals are frequently accumulated, and that is what we demonstrated here. Calculating the total. Right there, total of all the numbers between 1 and 100. You declare your accumulator above, and then you update it inside the loop. It wouldn't really matter whether it was a while loop or for loop or whatever, but it just makes it nice to have it all in one header like that. Starting point, the end point, and the increment. So we haven't seen a for each loop in this chapter, but I want us to. And a for each loop is when you need to access a data structure such as an array or a list. So not that we've talked about arrays yet, but you've seen them in other languages. So if we're going to create an array, let's just go down to the bottom right above our final, hit enter to quit. I'm going to create an array of strings. String. And they follow the Java syntax rather than the C++ syntax of putting the square braces after the data type rather than the variable name. And we're going to call this colors equals, and then we're going to create an initializer list. So inside some curly braces, we're going to list some colors. Quote red, end quote, comma, quote blue, end quote, comma, quote green, end quote, comma. Just type some colors in: orange, silver, and then finally at the end of all that, semicolon. Now there's two ways of accessing that array. One is we could use an index for I equals 0, I is less than the length of the array, I plus plus. That's one way to do it. Or another is just with a for each. Here's what the first way would look like. For parentheses int I equals 0. Got to start it off at I. Keep going while colors dot length. Wait. Keep going while I is less than colors dot length. Semicolon. And every time we add 1 to it. And let's just print that out. CW tab, print out colors subscript I. And so 1 per line, it's going to print red, blue, green, orange, and silver. That's one way of printing out an array. Here's the other way. And you saw this a lot in Java. In Python. Java supports it too. They have a for each loop. In C#, they actually use the keyword for each. Unlike those other languages, they created a new keyword to support the functionality. For each parentheses, string s in colors in parentheses, CW tab s. To me, this syntax looks a lot cleaner than this. If I had to step through an array or some kind of data structure and for each would work for me, I'll always go for each, just because the syntax is a lot cleaner. Doesn't mean you have to. This way works just as well. Let's run it and make sure. So if you're going to generate random numbers in C#, I believe we've covered that. Have we covered that? Random numbers, C#. It uses the random class. And so you can make a random object of that class, and then you can just call .next and specify the minimum and the maximum. And let's do that. Let's print out like 100 random numbers. So random R&D equals new random, parentheses in parentheses. And then we're just going to have a for loop that runs 100 times so that we can print out some random numbers. For parentheses int I equals 0, I less than, let's be good programmers like we were before. Const space int space rand underscore nums equals 100 semicolon. And then in our for loop, I equals 0 semicolon, I is less than rand underscore nums semicolon, I plus plus. Close parentheses, curly brace, CW tab, random number equals, let's actually store it in a variable. Int r equals R&D dot next. And we wanted to start at 1 and go to what? If I wanted to go up to 6, I'm going to have to make this comma 7. And then down here I could say random number equals end quote plus r in parentheses semicolon. So what is a random number? A random number is just a number. It's actually a pseudo-random number, meaning that it's calculated by an algorithm. We don't know the algorithm, so we can't predict the numbers in advance. If we set what's known as a seed value, it would generate the same sequence of random numbers every time. But since we haven't set the seed value is being set by some time factor, like the number of milliseconds since midnight or something like that. And so unless we ran our programs at the exact same instant in time, we're going to get different sequences. So if I scroll up, my numbers start with 414, and then if I run it again, it's going to generate a different sequence. 641, and so on. So why are random numbers cool? Well, you can test your algorithms. You're going to write something that's going to sort data. You might want to generate random numbers. On the other hand, you may want to see the same sequence generated every single time. And if you wanted to do that, you would just set the seed. RND dot. Ooh, it's not going to work. How do you set the seed? Set seed of C# random. Do you pass a number into the constructor? Looks that way. Yep. So if we specify a value between the parentheses here, that sets the seed. And it would generate the same numbers every time. So if I just set a seed of 1, then the algorithm is going to start from 1 rather than some time-dependent value. And so when I ran it the first time, it says 2135, and then if I run it again, I'm going to say the same thing. 2135. Now, if you were to make a game, it'd be pretty boring if your series of random numbers are the same every time. Like if every time you played Yahtzee, you knew in advance what the dice were going to be. You'd get real bored of the game. So you might not want to set the seed, but then again, you might want to. I think I'm going to get rid of that 1. You can pass in a seed argument to generate the same series of numbers every time. Example, new random parentheses 1. Okay. So the homework's just going to be based on the idea of random numbers, just to get us used to the idea. We're going to be using random numbers when we get to arrays, things like that. And it's more fun to do that, in my opinion, than write code that's going to ask the user to enter 100 values or 10 values or something like that. So homework. Write a program that asks the user how many random numbers to generate. The program will use a loop to add that many random numbers together using dot next int 1 comma max value, or max value. Max value plus 1. Define max value as a variable with the value 100. Then print the total and the average. How would you calculate the average? You just divide it by the total number, right? So if the user said they want 2,000 numbers, you're just going to divide it by 2,000. Wish I wasn't being so stubborn about putting asterisks everywhere, but I know why they're doing it. All right. That makes sense?
Can we scroll back up?
Yeah, sure. All righty.